Alright, so today I'll be explaining what is the Wumpus World. It's an AI problem, and I'm Rajeev Patnaik Rayagada. So, why should you care and what even is the Wumpus problem? So basically, the Wumpus World problem demonstrates the value of knowledge-based agents and the interpretation of the knowledge we get and using the reasoning and planning to find and achieve the goal, which in this case is to get the gold and come back home, which is at 1, comma 1, without dying. And so basically, it's a 4 by 4 grid, as we can see, and each square can contain agents and objects. Agents as in you, the player, and objects as in gold and pits. So the goal is to find the goal and return to 1, comma 1 and climb out of the cave without dying. So we have to watch out for the Wumpus, which is the monster right here at 1, comma 3, along with the pits, both of which can lead to the player's death. So this is the agent, this is the Wumpus, these are the pits. Right, so now we're going to go for the PEAS measurement, where P is the performance measure, E is the environment, A is the actuators, and S stands for sensors. Performance measure. We get 1,000 points to climb out of the cave with the goal, which is the goal of the game. We lose 1,000 points by death if we are killed by the Wumpus or fall into the pit. We lose 1 point per action, so the goal is to finish the maze with the least amount of actions as possible. We lose 10 points for using up the arrow without killing the Wumpus. Usually in this game, the player or agent is given one arrow, and there is one Wumpus in the game. So if we kill the Wumpus, we gain 10 points. But if we miss, that is, use the arrow and you miss the Wumpus, you will lose 10 points for that. So you have one arrow, you lose nothing if you don't kill the Wumpus and you don't use the arrow. If you use the arrow and you kill the Wumpus, 10 points. If you use the arrow and it's wasted and it doesn't kill the Wumpus, you lose 10 points. Now for the environment. So the player, which is the agent, always starts at 1, comma 1, facing right. The locations of gold and Wumpus are chosen randomly. So this gold could be anywhere except for 1, comma 1, and the pits could be anywhere except for 1, comma 1, because you can't just spawn into a pit. That would be pretty bad. So each square other than the start can be a pit, with a probability of 0.2, meaning each of these squares except for 1, comma 1 has a 1/5 chance of being a pit. Now for the actuators. So the movement actions are obviously going to be right, left, up, down, using the arrows, or WASD. Depends on the game. Some of them use that as well. Now you click enter to capture the gold, and space to kill the Wumpus, that is, shoot the arrow. Now the thing is, as I mentioned before, you have only one arrow and there's only one Wumpus. And killing the Wumpus gives you 10 points. Not killing it loses those 10 points. And not using the arrow itself will get you nothing. So, now the grab action is used to pick up the gold. How do you know when you're at the gold? Well, see, the gold glitters. We'll get to that soon. And shoot action, as I mentioned, fires the arrow in a straight line. Now, how do we know where it fires? Well, you use the arrows to point to the direction where it shoots. Suppose you're at like 1, comma 1 and you just shoot immediately. Since you're at the beginning and you're facing the right, what's going to happen is if you're lucky and the Wumpus is right next to you, it will kill it, you get 10 points. If not, which is more likely, it's going to continue until it hits the wall at 4, comma 1. And after that, you just lose 10 points because you didn't kill a Wumpus. Next, climb. Climb is used to leave the cave. It's only effective when the agent is at the start square after acquiring the gold. So you're at 1, comma 1. Can you climb? No. First you need to get the gold, come back to 1, comma 1, and then climb. That's how you basically exit the game and win. Now the agent dies if he enters a space containing a pit or a live Wumpus. So you enter these pits or you go to the square with the Wumpus in it. So 1, comma 3, you die. Note that if you kill the Wumpus, what's going to happen is it's going to show that it's smelly. The stench. We'll get to that in a moment. And you can go into that square after killing the Wumpus. And if you did kill it, you get 10 points. Good for you. Next, we've got the sensors. So stench is perceived by the agent in the square of the Wumpus, along with 4 squares directly adjacent, but not diagonal to it. So the Wumpus here, it's not actually shown here, but the stench is going to be in this box as well. So you've got stench because the Wumpus is here, adjacent only. So the adjacent boxes to the Wumpus, which is in 1 comma 3, is 1 comma 4, 2 comma 3, 1 comma 2, along with 1 comma 3. Now obviously minus 1 comma 3 doesn't exist, but if it were anywhere else, that's where it would be. Note that the diagonals do not have the stench. Breeze is perceived by the agent in the squares, directly adjacent to the pit. So it's basically the same thing as with the Wumpus, except that the square itself does not have breeze, unlike the Wumpus, where the square itself also has the stench once you kill it. So you've got a pit here, it needs breeze above it, below it, where in this case it's out of the map, but here below it works, next to it, which is on the right side and the left side. So same goes here. This is one perfect example. You've got a pit. It doesn't have breeze in it because you can't kill the pit. So you've got breeze below it. So in three column, one below it, one above it, one to the right, and one to the left. Next, we've got glitter. Glitter is perceived by the agent in the square containing the gold alone. So we've got gold. You can only find this glitter in this particular square, which happens to be 2 comma 3. Next, bump. What is bump? Whenever the agent tries to walk out of the labyrinth, that is, walks into the wall, you receive a bump. So in this case, you're the agent. You try to come out. So you're at suppose 1 comma 1 and you try to go to the left or down. Then you receive a bump and stay there. It's a waste of a move basically. Now a scream is perceived when the agent kills the Wumpus. So suppose the agent is here, you turn upwards, shoot the arrow, or you go to 2 comma 3, turn left and shoot the arrow, or 1 comma 4, turn down and shoot the arrow. These are the only three cases where you can kill the Wumpus. Or perhaps from 1 comma 1, you look straight up and kill the Wumpus by shooting the arrow, which would be with blind luck. All right, now for the knowledge-based environment exploration. How do we go about this? For this, we have to create our own code. So A is for agent, B is for breeze, G is for glitter or gold, OK is the safe square, P is the pit, S stands for stench, V stands for visited, and W stands for wumpus. This is just an example. It's not the one we'll be using for the next, but this is how it is. To make it more interesting and easier to understand, I've added little emojis. So at 1 comma 1, which is where we always start, we have the agent facing towards the right. So this little guy is the agent. And the first thing we have to notice is, do we feel any breeze or do we feel any stench? In this case, we do not. So from this, we can confirm that the box to the left and above it are free of pits and of wumpuses. So after this, we mark 1 comma 1 as visited and go to 2 comma 1. Once we go to 2 comma 1, we feel a breeze as mentioned here. So what does it mean? If there's a breeze, it means that there is a pit nearby. So in this case, remember pits can release a breeze, one below, one to the right or to the left or above it. So there could be a pit above, below, to the right, or to the left. Now we've already seen that it cannot be to the left because that's a restarted. There's no pit there. It cannot be below it because that's out of the map. So that leaves only two places possible for the pit to be, namely above it and to the right of it. So 2 comma 2 and 3 comma 1 are the possibilities that there's a pit. Now, once we have realized that, we go to 1 comma 2. So why do we go to 1 comma 2? The reason is we've already been to 1 comma 1, so we don't need to go there. We cannot go below because that's out of the map. We cannot go to 3 comma 1 or 2 comma 2 because there's a 50-50 chance of it being a pit. We want to survive, so we go back, leaving 1 comma 2 as our only option. Now, once we come to 1 comma 2, first thing we notice is that there's a stench. Next thing we notice is there is a lack of a breeze. Now, what does a lack of a breeze mean to us? It means there is no pit above us, below us, to the right of us, and to the left of us. Now, leaving the one below us, because that's where we started, to the left of us, because that's out of the map, This tells us that there is no pit above us and no pit to the right of us. Now, if you go before, we notice there's a possibility of the pit being above us or to the right of us. In this case, we have proven that the pit is not to the right of us over here. This proves that it is not over here, which means there's a 100% chance that the pit is over here. Thus, it becomes a proper um, pit. We know exactly where it is. Now, we know that these four squares are okay, but because of this stench, we know that the Wumpus is here, for sure. Now, after this, we go from 1 comma 2 to 2 comma 2 to 2 comma 3. We already know that 2 comma 2 is okay, so I didn't really go through that. It's simple. So after 2 comma 2, we go to 2 comma 3. So what do we notice at 2 comma 3? Well, at 2 comma 3, we notice the stench again. Now, since we've noticed the stench at 1 comma 2 and 2 comma 3, the only chance for it to be a wumpus is at 1 comma 3, because we know that at 2 comma 2 it is alright. So now that we know where the wumpus is, what else do we know? We feel that there's G. G stands for glitter or gold, meaning we have found the gold and we can go back now. We also feel a breeze, meaning as seen before, this is identical to the case here. We felt a breeze, so we know for sure there's one above it or to the next, to the right. Same goes here. It's above it or to the right. It cannot be below it. It cannot be to the left, because then you'd have a wumpus and a pit. So that would be pretty simple. Funny. Anyways, so now that we have the gold, we can go home, which is at 1 comma 1, and climb out to win the game. If you want, now that we know that the Wumpus is here, you can turn to the left and shoot your arrow. You will get 10 points for killing the Wumpus successfully. Now, how do we go back home to 1 comma 1? You can either go from 2 comma 3 to 2 comma 2, followed by 2 comma 1, followed by 1 comma 1, or 2 comma 3, 2 comma 2, 1 comma 2, 1 comma 1. It really doesn't matter, it's the same length. So yeah, that's how you beat the game. Hope you enjoyed and have any questions, be sure to comment.
Hello guys, I'm Surya. Today I'll be explaining problem solving in AI in this lecture. Now let us look into what is problem solving in AI. The ability of an AI system to analyze data, identify patterns and generate solutions to complex problems is called as problem solving in AI. Let us look into the steps involved in formulating the problems. First is problem identification. You must exactly identify what is the problem. After identifying the problem, a goal must be formed. The goal is the final state of the problem, that is, where the user or the system should attain at the end of the process. After goal formulation, we have problem formulation. This problem formulation involves all the constraints, actions, and the necessary information regarding the goal state. Next, we have the search solution. Based on the defined problem and the goal state, we must search all possible solutions to reach from the initial state to the goal state. Once we have all this information, we must proceed to the execution. Let's recap this once again. First step is goal formulation. That is, we must clearly define what is the final state. Then is problem formulation. Here we define all the constraints, actions, etc. Based on the given information, we must find all the possible solutions. Then we proceed to the execution. Now let us see the steps performed by a problem-solving agent. In goal formulation, it is the first and foremost step in problem solving. It organizes the steps required to formulate one goal out of multiple available goals. Problem formulation. It is one of the most important steps in problem solving, which decides what actions should be taken to achieve the formulated goal. There are 5 components involved in problem formulation. Initial state. The initial state is the first state or the beginning state where the problem is before starting. It is also called as the starting state. operators or actions. It is described as the all possible actions available to the agent to reach the destination state or the goal state. Transition model. It describes what each action does or what are the possible actions it has. Goal test. It determines whether the current state has achieved the goal state. Path cost. It assigns a numeric cost to each path that follows the goal. The problem with minimal path cost is said to be the best path. State space. Initial states, actions, and transition model together define the state space of the problem. A small note here. State space of a problem is a set of all states which can be reached from the initial state followed by any sequence of actions. Search. It identifies all best possible sequence of actions to reach the goal state from the current state. It takes a problem as an input and returns the solution as an output. Solution. It involves finding the best algorithm or the least path out of various algorithms available to reach the goal state. Execution. It executes the best optimal solution with least path cost to attain the goal state. Now we have clearly seen what is problem solving. Let us now solve an example. First, I'll read out the question. We are solving the water jug problem here. You have a 2-gallon jug and a 5-gallon jug. Neither have any measuring marks on them. Initially, both are filled. You need to get exactly 1 gallon into the 5-gallon jug. Find out a way to empty the 2-gallon jug and fill 5-gallon jug with exactly 1 gallon of water. What the problem says here is that we have 2 jugs with one measuring 2 gallons, another measuring 5 gallons. Both do not have any measuring marks on them, but we have surplus supply of water. Our goal is to fit exactly 1 gallon of water in the 5-gallon jug using only these 2 jugs. So, from the question, we can conclude that the initial state is a 2-gallon jug and a 5-gallon jug, and both jugs are filled up to the brim. Operators. Operators define all possible actions that can help reach us the goal state. Now we'll see what are the possible operators. We can have an empty 5-gallon jug or an empty 2-gallon jug. We can have a completely filled 5-gallon jug or a completely filled 2-gallon jug. We can fill water from a 5-gallon jug into the 2-gallon jug, or we can fill water from the 5-gallon jug into the 2-gallon jug. So these are all the possible 6 states. The goal state as specified in the question is that the 5-gallon jug must be filled with exactly 1 gallon of water and the 2-gallon jug must be empty. So we can clearly see the goal state and the representation here. Now we'll see how we must attain the goal state. As you know, the state space is a combination of initial state, action and transition model. Now we'll see how we will solve this problem. In the question we are clearly given we have a 5-gallon jug and a 2-gallon jug, and our goal is exactly to have a single gallon water left in the 5-gallon jug. So we first fill the 2-gallon jug to the brim and we transfer it to the empty 5-gallon jug. Now the 5-gallon jug contains exactly 2 gallons of water and the 2-gallon jug does not have any water. Again we repeat this process. We fill the 2-gallon jug up to brim and transfer its contents into the 5-gallon jug. Now the 5-gallon jug contains 4 gallons of water and the 2-gallon jug contains nil. Again we repeat this process. We fill the 2-gallon jug up to its brim and we transfer the contents to the 5-gallon jug. As there is exactly 1 gallon of water to be filled in the 5-gallon jug, we can only fill 1 gallon from the 2-gallon jug into the 5-gallon jug. After this is completed, we empty the 5-gallon jug. Now we have nil amount of water in the 5-gallon jug and exactly 1 gallon of water pending to be filled in the 2-gallon jug. Now we transfer the contents of 2-gallon jug into the 5-gallon jug. Now we have reached the goal state as the 5-gallon jug contains exactly 1 gallon of water and the 2-gallon jug contains nil amount of water. So now we are moving to the next example for problem solving in AI. As we all know, the Missionaries and Cannibals problem is a classic example of problem solving in AI. Now let us look into the states. Let the state consist of sequence of 3 numbers representing the number of missionaries, cannibals and the boat. So the state specifies that the initial state has 3 cannibals, 3 missionaries and exactly 1 boat. Operators. They carry 1 missionary, 1 cannibal, 2 missionaries, 2 cannibals or each one of them across the boat. The operator states that there can be exactly 2 persons at a time on the boat. The 2 persons may be exactly 2 missionaries, exactly 2 cannibals or exactly 1 cannibal and 1 missionary. Goal state. It is the state where missionaries and cannibals have reached from one bank to another. So the final state is 000. That is, all the missionaries and cannibal from one side of the bank have reached the other side. Operators. Putting missionaries and cannibal in a boats such that the cannibals do not outnumber missionaries and there may be 1 or 2 people in a boat at a time. The operator states that we must put missionaries and cannibal in a boat such a way that cannibals do not outnumber the missionary and there can be either 1 people or at max 2 people in a boat at a time. Path cost here specifies the number of crossings between bank 1 and bank 2. So let us now see the rules in carrying missionaries cannibal from one bank to another. Rule 1. 1 missionary sailing from boat 1 from bank 1 to another. Rule 2. 1 missionary sailing the boat from bank 2 to bank 1. Rule 3. 2 missionaries sailing at a time in the boat from bank 1 to bank 2. Rule 4, which is the reverse of rule 3, that is 2 missionaries sailing from boat from bank 2 to bank 1. Rule 5. 1 missionary and 1 cannibal sailing in the boat from bank 1 to bank 2. Rule 6. 1 missionary and 1 cannibal sailing in the boat from bank 2 to bank 1. Rule 7. 2 cannibals sailing in the boat from bank 1 to 2. Rule 8 is a vice versa of rule 7. 1 cannibal. Rule 9. 1 cannibal sailing the boat from bank 1 to bank 2. Rule 10 is vice versa of rule 10. Note, all or some of these production rules will have to be used in a particular sequence to find the solution of the problem. That is, we should use the above rules and it is not necessary we must use all rules at once. So now we will see how the problem is solved. First, we are given the initial state where 3 cannibals and 3 missionaries are at the initial state or at bank 1. Now, exactly 1 cannibal and 1 missionary move from one bank to the other. Now, a single cannibal returns from bank 1 to bank 2 to bank 1. Now, at initial state, we have 3 missionaries and 2 cannibals left. Now, 2 cannibals move from bank 1 to bank 2. Now at bank 2 we have 3 cannibals and in bank 1 we have 3 missionaries. Now from bank 2 to bank 1, 1 cannibal returns. Now we have 3 missionaries and 1 cannibal in bank 1 and 2 cannibals in bank 2. Now 2 missionaries sail from bank 1 to bank 2. Now we have 1 missionary and 1 cannibal in bank 1, 2 missionaries and 2 cannibals in bank 2. Now One cannibal and one missionary returned from Bank 2 to Bank 1. Now we have two missionaries and two cannibals in Bank 1, one cannibal and one missionary in Bank 2. Now, two missionaries move from Bank 1 to Bank 2. Now we have three missionaries and one cannibal in Bank 2 and two cannibals in Bank 1. Now, one cannibal moves from Bank 2 to Bank 1. We have three cannibals in Bank 1 and three missionaries in Bank 2. Now, two cannibals set sail from Bank 1 to Bank 2. Now we have one cannibal left in Bank 1, three missionaries and two cannibals in Bank 2. One cannibal returns from Bank 2 to Bank 1. Now we have two cannibals in Bank 1, three missionaries and a cannibal in Bank 2. As the last step, two cannibals move from Bank 1 to Bank 2. This is the final state where there are 0 cannibals and 0 missionaries in Bank 1 and there are all the 3 cannibals and all the 3 missionaries in Bank 2. These are the steps we follow to reach the goal state. As you can see, these are the steps followed, but as you can notice clearly, 2 steps have been crossed as because we have already clearly stated that the cannibals cannot exceed the missionary. In this figure, we see that there are 3 cannibals and 2 missionaries in the second bank, which is not possible as the cannibals are outnumbering the missionaries. From this lecture, I hope you understand problem solving with these examples. Thank you.